We're continuing our review with the test 2 material. All right, so we're up to radicals. All right, so here in number 1, we just want to take the cube root of minus 64. All right, so that is minus 4. All right, so you just work it out. Minus 4 times minus 4 times minus 4. All right, here this is 16, and 16 times minus 4 is negative 64. All right, question 2 is to simplify the square root of 27. All right, so 27 is not a perfect square, but we'll factor it as 9 times 3. 9 is a perfect square, so we can take the square root of 9, which is 3, and this simplifies to 3 square root 3. In question 3, we're just going to take the square root. 36 is a perfect square, so is x to the 16th and y to the 10th, because both exponents are even. Okay, so the square root of 36 is 6. The square root of x to the 16th, we get that by taking half of the exponent, so that would be x to the 8th. And the square root of y to the 10th, that's y to the 5th. In question 4, we're asked to simplify this 5th root. All right, well, 32 is a 5th power. In fact, it's 2 to the 5th. That's one of them. That's the only one that you should remember, that you should memorize. 2 to the 5th is actually equal to 32. All right, now x to the 20th is also a 5th power because we can divide 20 by 5. But y to the 32nd, we're going to have to factor. All right, so I'm going to actually circle the 32 because that's going to come out. And I'll circle the x to the 20th because that's also going to come out. And I'll factor y to the 32nd as y to the 30th times y squared, because 30 is divisible by 5. All right, so these three come out. The 5th root of 32 is 2. All right, to take the 5th root of x to the 20, we divide 20 by 5 and we get x to the 4th. And divide that exponent by 5 and we get y to the 6th. All right, so simplified, we have 2 x to the 4th, y to the 6th, and then we have the 5th root of y squared. In number 5, we're multiplying two radical expressions, which are binomials, and we'll multiply in the order of FOIL. The first times the first is 4 times 3, that's 12. And then we'll multiply the outer terms, minus 20 root 2. And then the inner terms, that's plus 9 root 2. And then the last, we have minus 15. And root 2 times root 2 is 2. Minus 15 times 2. All right, so this is minus 30. Okay. So now let's combine 12 minus 30. So we have negative 18. And now we'll combine negative 20 plus 11. So that's, sorry, negative 20 root 2 plus 9 root 2, and that would be minus 11 root 2. In number 6, we're dividing two radical expressions, and we're going to use the following rule. The square root of a divided by the square root of b is the square root of a over b. So basically this says if we are dividing two radicals, we can divide underneath the square roots. All right, so we'll put this expression under one large square root. So that's 3x to the 5th y cubed. And here we have 27 x cubed y. And just reduce that expression underneath the radical. Right, first let's divide the 3 into the 27, or cancel top and bottom. Divide top and bottom by 3, and so we would have a 9 in the denominator. Now let's work on the x's. X to the 5th divided by x cubed leaves us with x squared in the numerator. And we have y cubed divided by y leaves us with y squared in the numerator. And now this is a perfect square in the numerator and same thing in the denominator. So let's take the square root, and we get in the numerator we have xy and 3 in the denominator. In number 7, we want to combine two radicals, but at the moment they're not like radicals. So we're going to try to simplify and see if we can get like radicals. Let's start with simplifying the square root of 45. We want to factor 45 into a perfect square times something else. Well, 45 is 9 times 5, and 9 is a perfect square. All right, so we're going to be pulling out the 9, or taking the square root of 9, and bringing a 3 in front of the radical. All right, so we'd like to be left with, we'll be left with a 5 here. We'd like to be left with a 5 in the second radical as well, so that we'll have like radicals. And we notice that 80 is equal to 16 times 5. And 16 is also a perfect square, so that's going to come out, and we will be left with the 5. Square root of 16 is 4. So let's rewrite this. So we have 3 root 5 plus 4 times 2, that's 8 root 5. And that's equal to 11 root 5. All right, now we're going to rationalize this denominator. That is, we want to get rid of the radical from the denominator. All right, so let's do that by multiplying by square root of 6 in the numerator and denominator, because the square root of 6 times the square root of 6 is 6, so in that way we'll be removing the radical. So in the denominator we have 5 times 6, and in the numerator we have 3 root 6. All right, so that's equal to 3 root 6 divided by 30, and we can reduce this. Let's divide by 3. Okay, so we have root 6 over 10.